Welcome to the first of two short presentations that I'll be presenting today. The format will be two 15-minute presentations followed by Q&A at the end. So now I'm going to talk about plant floor technologies and share what we've learned through recent work, and then later I'll demonstrate our new plant floor offering and discuss that in further detail. You can expect to get an understanding of what serial communication means compared to parallel communication. I'll also help you understand RS-232, USB, and TCP/IP formats, which are the three main technology protocols that plant floor equipment use. And I'll further help you understand the Internet of Things and separate some of the facts versus marketing fluff associated with those concepts. So, who am I? I'm Roger Kirkness. In case you don't remember me, I've been with Minotaur for 4 years, and I'm second generation family here. I started out in sales and switched my focus recently to our new plant floor offering, Catchmate. I've learned a lot about plant floor technology through this process, and that's the knowledge that I want to share with you today. So, plant floor communications means any data sent or received by devices on your plant floor. Some examples that fall under that might include printers, scales, sensors, PLC units. And there's really two forms of communication that can take place, and the first being serial communication, which means that data is sent in sequence over one wire, and then parallel communication just means the data is sent in parallel along two or more wires from the device to the host. So each have strengths and weaknesses that I'll refer back to during the presentation. The first generation is called RS-232, and that's a serial format. So all plant floor communications were originally serial, and RS-232 is one of the first and most common serial formats in use. Printers, scales, PLCs, and machines all use this format at one point in time. It didn't really allow for wireless communication or much networking between machines, but it did enable people to connect machines and equipment up to controllers and indicate that what was happening on the plant floor, which made it easier to control plant floor activities. So this format's still in use, and it does work well for specific purposes, but it does not allow for wireless connectivity or networking. Some of the strengths of the RS-232 format are that it's great for simple applications, and it's still used in things like keyboards, mice, charging, and it's inexpensive and great for long-distance communications as well. Among the weaknesses include that RS-232 is inefficient and slow for complex applications. It's a lot easier to send things over multiple wires than one. It cannot offer wireless connectivity, more expensive and complex than the existing serial cables, and it requires large connectors in order to be effective. So the second generation that replaced serial in terms of universal use is called the Universal Serial Bus, which again is another serial format. So it's the current standard in serial communication. Those things like mice, keyboards, and charging, simple applications that don't really require a lot of communication, they still use a serial format, which is USB. The strengths to USB are that it is fast and efficient compared to RS-232 in the original serial formats. It's very reliable and inexpensive compared to more complex parallel formats. It can't run longer than 5 feet with a USB cable, and it's not as efficient as parallel communication is for communicating complex data back and forth. And it's generally only a one-to-one relationship between the device and the host, which in most cases is some kind of computer. So the weaknesses of USB are mostly involving communicating complex information over a longer distance and creating a network between devices. The third generation of communication protocol is called TCP/IP, which is the first parallel format that we'll discuss, and it basically stands for Transmission Control Protocol and Internet Protocol, which is the technology that underlies the internet and mobile data networks that we use. And what it does is send data in packets along a parallel interface, meaning several wires are involved. So the common uses include things like networks, the internet, and websites, where you need to send complex information along a variety of wires to get to the client. So you need the ability for the message to be split up and then recombined when it gets to the host. So the strengths of TCP/IP include that cables can be run long distances without data loss. You can communicate in parallel, which means more complex transmission and faster communication. It more easily allows devices to communicate with each other. And it offers easy to configure one-to-many relationships or many-to-many relationships, which is really the definition of a network. Further, it offers the ability to connect more easily using wireless technology. The weaknesses are basically that it's more expensive than serial formats per length of wire, just because there's multiple wires inside the insulation, and it's not as efficient for simple interactions like mouse clicks. Some examples of devices that have recently been converted to TCP/IP include scales, printers, scanners, receiving, sensors, anything that requires tracking more complex information is something that has been converted to a TCP/IP format, basically because it's a lot easier to use a parallel format for that application than it is to use something like USB. So in the future, this concept of Internet of Things has been taking over people's discussions, and so it seemed like a fitting time to discuss it. The Internet of Things just means hardware devices that are connected to the Internet. So this technology has existed for decades. The difference is that the focus is on requiring people to buy new hardware. So the Internet of Things does not represent any kind of technological revolution or existential threat to your business. It's really just anything that connects to the Internet and is hardware as an Internet of Things device. So I think the excitement among vendors is more the benefit of having your data bringing them than the potential it has to make a difference for your business. Networking your plant floor equipment with on-site servers can have benefits that I will discuss, as can running your system in a virtual environment. It really comes down to how you do it. So what we think Internet of Things done wrong looks like is that it requires always-on cloud connectivity. It requires support from the vendor for the device to function, so if the vendor ever discontinues support, then you no longer have the ability to use the device. So our advice would be own your hardware and run your software locally. And this is something that people are learning the hard way in many consumer products and technologies. And really there's minimal benefit to hosting it off-site unless there's a lot of data processing that's involved and you just simply cannot afford the infrastructure. Even then, it often makes sense long-term to purchase your own infrastructure compared to renting it from someone else. So Internet of Things done wrong looks kind of like this product called the Revolve, which is a smart home product that allows you to network all of your different house controls together, things like fireplaces and light switch and locks. What happened was the company bought Revolve and decided to discontinue the product, but in doing so, they actually prevented it from working. So you have this device which is networked to all the controls in your house, but it is completely useless. It's just bricked. So you have to rewire everything, and it's quite a frustrating process. So in general, a similar thing could happen with your business with pretty detrimental effects. And the best thing to do long term is just to make sure that all the hardware and infrastructure and software that you depend on is located on your site and or somehow under your control in order to protect yourself from issues like this. There is a way to do Internet of Things right, and this hopefully is the basis of a lot of people's excitement. So TCP/IP, the protocol for communication that we talked about, can be used on your own private network. You don't need to be connected to the Internet to be networked. It does not require an Internet connection to the world in order to work, so you want your device to be entirely contained on your network. There's no vendor lock-in, no always-on connection, you just get better data. So TCP/IP is the technology, is great for plant floor equipment, and it allows you to stay in control, but we would recommend using it only within your controlled network and not using it in the broader internet, which will also prevent access from hackers and other threat actors. So to illustrate a little more what Internet of Things done right looks like, if there's no internet, there's no problem, there's no need for internet access. There's redundancy of data on the client, so even if you drop connection temporarily, you can continue processing on the plant floor. You can protect internet devices on your private network, and you can control your devices from the office. Where's the technology going in the future? So we think the future looks mostly like TCP/IP and network devices, and then you'll continue to see USB for simpler formats like mice and keyboards that don't require much networking. All the tech to do this already exists, and the prices are coming down every day, and the reliability hopefully is increasing. So we think that TCP/IP and USB formats, which is both parallel and serial, they both have a role to play in connecting hardware devices in the future. So we're continuing to invest in R&D in this area, and that's something that I'll discuss next. So that covers the first half of the presentation. If anyone has questions, feel free to ask. You can also visit our website, www.minotaursoftware.com, in order to get more information about this technology. We want to hear your suggestions for devices that we can connect to. And now we'll move on to demo our new plant blower offering, Catchmate. Thanks.